Good evening or good afternoon, my YouTube viewers. It's Crystal here, and I wanted to make another video for you. And what I wanted to do in this video is I wanted to give you a geometric distribution in Excel. And the thing about Excel is it doesn't actually say geometric. What you have to do is you have to go to neg binum, and then that will give you your geometric distribution. I'm not sure exactly why they call it a neg binum, but that's what you have to use to get a geometric distribution. And basically, if you want to know how to do a geometric distribution, you have to know a little bit about the Bernoulli distribution. Whereas the Bernoulli distribution, you get like two outcomes, success or failure. But what the geometric distribution does is it tells you how long you have to wait until you get a success and what the probability of that success is. So that's where the geometric distribution differs from the Bernoulli distribution, but you need to know the Bernoulli distribution and understand how the Bernoulli distribution works before you can get into the geometric distribution, which is quite interesting indeed. So the first thing that we're going to do is you have to put your number of failures in, and that's in column A of your spreadsheet. And then on column B, 15 and 16, you put in the probability of success, which at this point we said 0.5, and required success, that's how many, the number of how many is required to be successful. In this instance, we put 4. And this is here, this is your number of failures. So it goes all the way up to 0 to 10. And if you want the geometric probability distribution function, that's PDF, you have to use the formula equals neg binum dot dist, brackets A3, comma, $B, $16, comma, $B, $15, comma, false. And the dollar signs tell you that these are absolute references, which means the reference won't change. So that's what you need. That's what's good about the dollar signs. And then if you want to have the cumulative distribution function, it's exactly the same formula, except at the end it's true. So the cumulative distribution formula is a true, and the probability distribution formula is a false. And that's the only difference between these two formulas. So what we'll do is, if you want to look at the geometric distribution formula, you can see with a probability of success is 0.5 and required success is 4. So what we can do is we come over here to 2, and we can change our, and what that does is that changes your distribution, and you can see how that has changed your distribution. And we'll move it to 3. And again, you can see how that has changed your distribution. So you can experiment with that, with your probability of success and your required success. So we'll change the probability of success over here to 0.35. And again, you see that that changes your distribution as well. We'll change the required success to 4. Again, you can see that, and now we're going to change it to 2. You can see that that changes your distribution, the probability of success and the required success. And then to get your cumulative distribution function, and that's an accumulation of all of these successes, and you can look at that as well. But the one that we're primarily concerned with is the probability distribution function. So what I want to do now is I want to show you how to actually make a chart. So we'll come over here and we block off the chart that we want to make, and we come over here to insert and we do recommended charts. So we've already done the scatter plot, but what we can do is we can do a cluster column. And so you can see we've got a cluster column. And that's just a little bit different way of looking at it, really. And then if you want to see the cumulative distribution, we block it off and we insert recommended charts, and we'll do a cluster column as well. And so that's how you do it, and you can make any type of chart that you feel is appropriate for your needs. And what I did was I originally did a scatter plot, and then after I did the scatter plot, I did the cluster plot. And so I've shown you two different types of charts that you can make doing the geometric function. So that concludes this video on how to create a geometric function. So you can experiment with it. You can experiment with the number of failures, probability of success, and required success, and see how that affects your distribution. So I'm going to go ahead and conclude this video. I'd like to thank you for watching it. If you like it, please like and subscribe. And I will be communicating with you in the next video. And we will be going over some more statistical distributions.